my name is Andy Fox, and I work at the Space Telescope Science Institute in Baltimore, Maryland. And we are the Science Operations Center for the Hubble Space Telescope and the James Webb Space Telescope. So I work with telescopes in space. I'm an astronomer, and I use those telescopes for my research. And my research is interested in galaxies like the Milky Way, how they form, how they evolve over time, and how they end up looking the way they do in the night sky. Well, we think that most of the matter in the universe is not made up of atoms and molecules and the type of matter that we see around us on planet Earth, but is made up of what we call dark matter. And dark matter doesn't emit any light. It doesn't shine. And that makes it very hard to study because you can't see it the way we can see normal matter. In fact, the only way you can really detect dark matter in astronomy out in space is by seeing its influence through its gravity. Because it has gravity and it pulls the matter and the stars around it in its orbit. So we can infer that dark matter is out there, but we can't see it directly. And theories in astronomy of the way that galaxies form and how they've changed over time actually predict that most matter in the universe is dark. It's not made up of atoms and molecules. But it's very difficult to get information on something that doesn't shine and doesn't emit light. And that's why we're excited about our new results, where we found a new way of potentially detecting or inferring that dark matter is present. Yeah, so Cloud-9 is a really interesting object in space. So it was found about 3 years ago by a Chinese radio telescope. In China, they have what's called the FAST telescope. It's a 500-meter diameter radio dish. It's the largest single dish telescope anywhere in the world. And it's a very sensitive radio telescope. It's able to see very faint signals. And with that telescope, they were studying a nearby galaxy. It's called M94. It's the name the astronomers give to it. And they were studying that galaxy. And when they surveyed that galaxy in radio light, they found this tiny little compact clump. And they gave it the name Cloud-9. And that was because they found 9 clouds around this galaxy, and this one was the 9th one in the series. So it just was given the very down-to-earth name Cloud-9. But the more we looked at this cloud, we realized there was something very unusual about it. It was very compact. It just looked like a tiny little speck on the sky, but it was so far away that it actually contained a lot of mass. And then we followed up on that cloud with the Hubble Space Telescope to see what does it look like in optical light. And that's the work that I was involved in, because when we followed this cloud up with the Hubble telescope, we expected to find stars, because if this thing was some sort of faint galaxy, it should have stars in it. That's one of the main properties of a galaxy, is it contains stars. But we pointed the Hubble at this thing, we stared at it for a long time, and we couldn't find a single star. It's a completely starless cloud. And that's what makes it so interesting and potentially a new class of object, is that it has a lot of gas in it, and we think it has a huge amount of dark matter holding the gas together and providing the gravity that holds it together, but it doesn't have any stars. And that's why we're so interested in it, is it's the best example we have of one of these starless gas clouds. Yeah, absolutely. So this is why we're so interested in Cloud-9, is we've actually been looking for objects like this. They've been predicted from theory that they should be out there. These clouds should be out there. So why is that? Well, we think that early in the universe, before most galaxies formed, there was mostly just gas, just an empty sea of gas, an ionized gas, which we call plasma, out there in the universe. And some regions were a little bit denser than other regions. And the denser regions started to collapse on themselves because of gravity and ended up becoming galaxies. So the places with the most mass started to collapse down and form galaxies. But that only happens above a certain mass, because you need enough mass to make a galaxy. So only the bigger objects would have collapsed to make galaxies. The smaller objects wouldn't have made it. They would have been failed galaxies. They would have been gas clouds that just didn't have enough mass to collapse down and start forming stars and become a full-fledged galaxies. Those were the failed galaxies, and that's what we think we may have found with Cloud-9. We finally found one of these clouds that we think is a leftover failed galaxy from the time when the universe was forming a lot of galaxies, but only the massive ones made it. The ones that weren't quite big enough just stayed as these clouds, these ghostly clouds without any stars in them. And that's what we think Cloud-9 is. We call these things relics because they're kind of a relic, like a fossil left over from the time when galaxies were forming, but not all the gas clouds made it. And we think we've now found one of this example of the failed galaxies or relics. Well, I think there's at least two things we need to do. We need to go with even more resolution, which means even more detailed radio images of Cloud-9 to start looking at its inner regions and to start seeing what its shape looks like in the center of the cloud. We're hoping we could potentially learn more about dark matter that way, because we think this is a dark matter dominated cloud. So the more information we get about what's going on in the center of the cloud will tell us how the dark matter is distributed. Is it concentrated in the middle, or is it spread out throughout the cloud? We need more observations of the inner regions of this cloud to tell us that. And the other thing we need to do is we need to find more examples. Cloud-9 is an excellent example, but it's only one. We need to find other examples of these types of object that we can follow up so we can really study them as a new class of objects rather than just this single one. I was always interested in space, even as a kid. I mean, I got a pair of binoculars when I was in middle school, and I would go out and I would look at the moon and I would look at constellations in the night sky, and I always found that interesting. So when I went to college, I started out doing physics in college, but I realized that I was just so interested in astronomy, I wanted to get back into it. So I moved into astronomy when I was in college, and I've stayed working on it ever since. It's just always appealed to me as something asking really big questions, really interesting questions, and telling us something about where we came from and what our place is in the universe.